Welcome to Dr. RCM Academy. So, in this session, we are going to solve one problem on divergence, and it is asked to find what is the numerical value of divergence of D at a point specified. See, for the first question, the point specified is where D is given, which is 2 rho z square into sine square phi and so on, and they have also specified the point. So the point specified is it is at a point B where rho equals to 2, phi equals to 110 degrees and z is equals to minus 1. This is the point mentioned for this question, that is vector D. So by looking at this equation, so as we know, it is with respect to rho, phi and z are the unit vectors. When rho, phi and z are the unit vectors, then we know that it belongs to cylindrical coordinate system. For cylindrical coordinate system, so we know what is the divergence of vector D. That is del dot D equals to 1 by rho into dou by dou rho of rho into d rho plus 1 by rho into dou by dou phi of d phi plus dou dz by dou z. This is the equation for divergence for a cylindrical coordinate system. Now we need to substitute for d rho, d phi and dz from the given equation, that is vector D. If I consider this is your d rho, this is with respect to d phi and this is your dz. So I have to substitute the values of d rho, d phi and dz from this equation, and I have to differentiate this partially with respect to rho, phi and z. So if I substitute, then so del dot d can be written as 1 by rho, I'll write as it is, dou by dou rho of, so here rho is there, so I'll write it as it is, into, I'll substitute in place of d rho, the equation given was, it is 2 rho z square into sine square phi plus, so I'll write the second term, that is 1 by rho as it is, dou by dou phi of, so in place of d phi, so what was given in d phi is rho z square sine 2 phi. This is the value given as a dou phi plus, so dou dz by dou z, dou by dou dz by, so dz in place of dz I will write it as 2 rho square sine square phi, it is given. Now, so let us differentiate this, simplify 1 by rho into, see here I am partially deriving with respect to rho, therefore the other parameters like 2z square sine phi is constant, so I can bring it outside. So therefore, so it becomes 2z square into sine square phi is constant, I'll bring it outside, dou by dou rho of, so you have rho into rho, that is rho square. So what is the differentiation of rho square is 2 rho. So I have first term is done. Coming to the second term, 1 by rho I'll write it as it is. Now I am differentiating with respect to phi, that is sine 2 phi I have, the rest is constant, I can bring it outside, that is rho into z square. So what is the differentiation of sine square, sine 2 phi is 2 into cos 2 phi. 2 into cos 2 phi. Similarly, so if I differentiate the third term, so we are doing with respect to z and there is no z terms here. Therefore, I will bring entire thing constant 2 rho square into sine square phi. So differentiation of, So we in the given it is 2 rho square z is there. So I will bring 2 rho square sine square phi as constant. So differentiation of z with respect to z is 1. So this is the partial derivatives that what we have done. So for divergence of vector d. Now I'll further simplify this. That is del dot d equals to, so rho and rho get cancels. You will remain with 2 into 2, that is 4 z square sine square phi, plus again rho and rho get cancels. You will remain with z square 2 into cos 2 phi plus 2 rho square into sine square phi. This is del dot d, that is divergence of vector d. But we need to find at a point given. What is the point given? Rho equals to 2, phi equals to 110 degrees and z equals to minus 1. So wherever rho is there, I will substitute 2, phi L is there 110 degrees, and wherever z is there, I will substitute it as minus 1. Therefore, the above equation can be modified as del dot d equals to 4 into, in place of z, I will write it as minus 1 sine square, in place of phi I will write it as 110 degrees, plus similarly second term 2 into z value is minus 1 cos 2 into phi value is 110 degrees, plus third term, so it is 2 into rho is given as 2, therefore 2 square is 4 into sine square of 110 degrees. Just I have substituted what is the values for rho, z and phi. So therefore, so if you simplify this, del dot d at a point b, which becomes 9.06. This is the divergence of vector d. This is the first sub question. This is the second sub question given. So it is d as given as 2r sin theta cos phi along ar plus r cos theta cos phi along theta and minus r sin phi along phi. And the point given is PC, that is the points r is equals to 1.5, theta is 30 degree and phi is 50 degree. We need to find, so what is del dot d? So divergence of vector d, this is what we need to find. Before we find this, so first we should find out which coordinate system it is. So the unit vectors are ar, a theta and a phi. These unit vectors belongs to spherical coordinate system. For spherical coordinate system, what is del dot d? It is 1 by r square into dou by dou r of r square into dr plus 1 by r sin theta dou by dou theta of sin theta into d theta plus 1 by r sin theta dou phi by dou d phi by dou phi. This is the del dot d, divergence of vector d for a spherical coordinate system. Hence, so if I find out what is dr, d theta and d phi from the given equation, so this is the coefficient of r, 2r sin theta cos phi. This is the coefficient with respect to theta and this is with respect to phi. So just I want to substitute this in the place of dr, d theta and d phi. Therefore, this becomes del dot d equals to 1 by r square, I'll write it as it is. So into dou by dou r of the first term r square also I'll write it as it is, and I'll substitute for dr, that is, so it is 2r sin theta into cos phi from the given problem. So it is given it as 2r sin theta cos phi. So plus, so I will write the second term, that is 1 by r sine theta into dou by dou theta of sine theta. I'll write it as it is, and I will substitute for d theta from this equation. So what is d theta? It is r cos theta into cos phi, r cos theta into cos phi. Now the third term, I'll write down the third term, that is 1 by r sine theta. I'll write it as it is. So you'll remain with dou by dou theta of. So you have d phi. What is d phi? So it is minus r into sine phi. So all the three terms are represented. So now I am going to derive it. Okay, so that is del dot d equals to 1 by r square, 1 by r square into, so I am doing with respect to r. This is with respect to r. So whereas the rest is constant, so I can bring it outside. So therefore it becomes 2 into sine theta cos phi. I'll bring it as a constant outside. So integration of, so it is 2, sorry, integration of r square into r, that is r cube, so which I can write it as 3r square. So whereas r square and r square can get cancels. So this is the first term. Coming to the second term, so it is r divided by r sine theta, because I am doing with respect to theta. So the rest is constant. So r divided by r sine theta into cos phi. So therefore here, so r get cancels, it remains with cos phi by sin phi. So whereas, so this is, it is in the form of, so sin theta into cos theta. So I can write it as, so it is sin 2 theta is 2 sin theta cos theta, or sin theta by 2 can be written as sin theta into cos theta. So integration of sin theta by 2, so r 1 by 2 I can bring it outside. So integration of sin theta is cos 2 theta into 2. So again 2 to get cancels, so you'll remain with this. This is the second term. Coming to third term, that is this one. So I'll write 1 by r sine theta as it is, and so if you look into this term, entire thing is constant because we are doing with respect to theta. So therefore, so this becomes, sorry, this is phi. So therefore the third term is with respect to phi, therefore it is 1 by r sine theta into, okay, so minus r is constant, I can bring it outside. So differentiation of sin phi. So if you take differentiation of sin phi, so it is minus, differentiation of sin phi is minus r is constant anyhow, so differentiation of sin phi I can write it as cos phi. If you further simplify, so you get r and r get cancels. So and therefore I'll rewrite this equation, del dot d equals to, so it is 3 2s are 6, you will get it as sin theta into cos phi, and the second term it is cos phi divided by sin theta into, so you will remain with cos 2 theta, and third term is minus, so you will get cos phi divided by sin theta. So this is del dot d, that is divergence of vector d, and now I have to substitute at pc. So what is pc given? R is equals to 1.5, theta is equals to 30 degree, and phi is equals to 50 degrees. So therefore del dot d is equals to, so it is 6 into sine of, what is theta? It is 30 degree into cos phi is 50 degrees plus, so it is cos phi, cos 50 divided by sine theta. Theta is 30 degree into cos of 2 theta. So 2 into 30 degrees minus cos 50 degrees divided by, so you will get sine theta is 30 degrees. So therefore, del dot D at a point PC, if you simplify this substituting in the calculator, so you will get del dot D in PC is 1.28. This is the divergence of vector D at this point. Thank you very much.